This is our second video in Chapter 6, Question 2, and we will be looking at bond pricing with the time value of money. Let's look at our scenario. On January 1st, 2010, JJC issued 8% stated rate bonds with a face amount of $10 million. The bonds mature on January 1st, 2015, in 5 years. The market rate of interest for similar bond issues was 7%. We have two assignments here. The first one being determine the price of the bonds on January 1st, 2010 if interest is paid annually. And the second one, determine the price of the bonds on January 1st, 2010 if interest is paid semi-annually. Let's go ahead and look at our first assignment. Let's look at our first question. Determine the price of the bonds on January 1st, 2010 if interest is paid annually. And I've highlighted a couple things up here to remind you. The company's issued 8% stated rate bonds, face amount at $10 million. They mature in 5 years on January 1st, 2015, and the market rate of interest for similar bond issues is 7%. So then we have what the bond promises. It's 5 annual payments of $800,000. These are interest payments, and that is calculated from the face amount, $10 million, that we got up here, times the 8%, which is the stated rate bond. So that tells us what the interest rate payments are going to be annually, because remember, interest is being paid annually in this problem, and it's going to be $800,000. So then we have the one payment of $10 million for the face amount as well on January 1st, 2010. So what we need to do is separately calculate the present value of both of these. So we'll calculate the present value of these 5 annual interest payments of $800,000 and then the one $10 million payment on January 1st, 2010. So let's start with the interest payment. So we know here the payment is going to be $800,000. So we can put that in. And next we need to figure out the present value of an ordinary annuity factor for the interest payment. So we know our number of periods here is 5 because it matures in 5 years and interest is being paid annually, so once a year. And then we always use the market interest rate when we're calculating present value. So we know it's 7%. So let's look at our table and see what the factor is at 5 for our period and 7% for our interest. So when 5 is our number of periods and 7% is our interest, we go down the line here and we find that our factor is 4.10020. So we'll plug that in on our table. So let's fill in the 4.10020 and we multiply our $800,000 interest payment by that present value of an ordinary annuity factor, and we'll get our total, which is going to be $3,280,160. Now we jump down to find the present value of our one-time $10 million payment on January 1st, 2010. For that, we're just going to use the present value of $1 since it's one single payment. So we fill in our $10 million here. And then we need to find the present value of $1, again, at n equals 5, I equals 7%. So let's look at that table. So when n equals 5, I equals 7, we come down here all the way to 7%, and we find our present value $1 factor is 0.71299. Let's fill in our factor, 0.71299. And then we multiply that by the 10 million, and we find the present value of that payment, which is going to be $7,129,900. And now, to find the selling price of the bond, all we have to do is add the present value of the face amount plus the present value of all our interest payments. So when we add those together, we get a total of $10,410,060. So that's how we calculate the selling price of the bond using present value factors when interest is being paid annually. Let's look at our second question now. On to our second problem. Determine the price of the bonds on January 1st, 2010 if interest is paid semi-annually. So the scenario is completely the same. The only thing that has changed is interest is now being paid semi-annually rather than annually. So we look down here, the bond promises now 10 semi-annual payments of $400,000. So how do we get that? Well, if you think, when there were annual payments, we had 5 and it was $800,000. So we simply took it, multiplied our periods times 2 to get us 10 periods, and divide our $800,000 by 2 to get $400,000 for semi-annual payments. Another way you could have done is taken the $10 million face amount and multiply it by 4% for semi-annual payments, which would have been the 8% annual rate, divided by 2, which would give you the 4%. Then second, we will again calculate also the present value of the one $10 million payment on January 1st, 2010. So let's start with the interest payments. They are $400,000. And for this one, we'll again be calculating the present value of an ordinary annuity factor. This time we will use 10 for our periods because it's semi-annual payment. So we took the 5 years to maturity and multiplied it by 2 to give us 10. And since it's semi-annual, we'll also have to divide the market interest rate by 2, which gives us 3.5%. So let's look at our table to figure out what the factor is for this. Looking at our table, at 10 periods, 3.5%, we get 8.31661 to use as our factor. So we'll plug in that number. And when we multiply that by 400,000, we get our present value of our interest payments, which is going to be $3,326,644. Now we come down to do our one $10 million payment to find the present value of that. Again, let's look at our table to figure out what the present value of $1 is with 10 periods at 3.5%. At n equals 10, I equals 3.5%, we get 0.70892 as our factor. So we will fill in that number, 0.70892, multiply that by 10 million, and we get 7,089,200. And just like last time, we're adding the present value of our one-time $10 million payment plus the present value of our total interest payments, and that's going to give us a grand total of $10,415,844. So you'll notice in both problems that the selling price of the bond was greater than the face amount that we were given in the problem. So why would the price be higher? That is because they're paying interest on these bond payments. So with the interest being paid annually, that increases the amount of the total price, and there with the present value, even still, you'll see it's going to be greater than the face amount.